In this video, we're going to learn set operations. So we're going to use this example to do all the different set operations. So here, we are given three sets. If we look at the description here, we have set notation, but this is different from what we learned before. So we could make a list of the numbers if we know what they are in there. For example, if we know the list contains 1, 2, 3, these three numbers. But if we have infinitely many numbers, then we cannot list all of them. So what we do is we describe it. For example, we first describe, we write down x, a variable x, and x belongs to R. R means all real numbers set. So this pretty much tells us x is a real number. And then we draw a vertical line right here. And then next we're gonna describe what kind of real numbers x is. And so in this case, it says x is less than or equal to 0. So the description here, x is less than or equal to 0. And over here, x is greater than -1. And it does, so the numbers, because x is a real number, so if we draw a real number line to describe that, it will be the numbers between -1 and 0, including 0, but not including -1. So it's all the numbers here, and there are infinite many of them, because we could have, say, -1/2, -1/3, -3/4, negative, lots of them, and could be irrational numbers too. So there are infinite many of them, so we can only describe it. We cannot list all of those numbers. And B is, if we draw a graph to describe the numbers, x, first of all, what kind of numbers are in B? So it's x. X, what is x? X is a real number. And what kind of real number? And after the vertical line, it tells us x is a real number between 0 and 1, and including 0, not including 1. So all these numbers here. Let me use red color to highlight these numbers and these numbers. Okay, the next one, C, x is a real number, and x is between -2 and -1/2. So say this is -1, this is 0, -1/2 would be somewhere here between -1 and 0. And so if we describe the numbers, it's including -2, so I draw a bracket there, and not including -1/2, I draw a parenthesis. Okay, so that's what we learned in algebra class. We can draw, use a bracket to describe including that endpoint, parenthesis, not including the endpoint. Okay, so now we can look at the operations. So first one, let's do A union B. Union means any number that is either in A or in B. Be careful, they don't have to be in both of them, just either in A or B. So this one is A, this one is B. So let's look at a union. So we're going to kind of put them together in one, if we combine it in one number, on one number line. So let's describe it. So I'm going to draw another number line here. Maybe I put it over here. Okay. First of all, let's draw all the numbers in A. So that's between -1 and 0, including 0. And then we draw all numbers in B. That's from 0, including 0 again, to -1. Okay, as we can see, 0 is in both of them. Of course, it's going to be in the union. But these numbers are only in A. They're also going to be in the union, because they just need to be in one of the sets in order to be in the union. So when we describe it, we follow the notation. X, first of all, x is a real number. X is a real number, and x is, as we can see, combine all of them, we get x between -1 and this is +1 and +1. So this part is set A, this part is set B, and put them together, union, you put all of them together, we can get this answer. Okay, now next we do intersection. We can still use the graph that we draw here. As we can see, we use red color, that's set A, and this is set B. With intersection, we're looking for the numbers that are in both of them. As you can see, there's only one number that's in both sets, and that's both ranges. That's the number 0. So there's only one number, which is 0. Well, I guess we can still do this format, x equals 0. Or you can just list 0 because there's only one number. We don't have to describe it. We can list it. Over here, there are infinite many of them, so I had to describe it. Now, next one, so we do subtraction, a minus b. And so remember the definition, we start with the set A, all these numbers, and try to take away the numbers that from A that is also in B. As we can see, there's only one number that is in A and in B, so that's 0. So we're going to have to delete 0 from set A. So that will be, so the answer will be, so we get rid of the equal sign right here, because 0 is in B, and this minus B means we have to get rid of the numbers in B from A. And next we do a complement. Complement of set A. In order to do the complement, we need to know what the universal set is. So the universal set is real number set, all real numbers. So we draw actually we can look at this graph right here, because this is set A. And complement means anything not in A. Well, because the universal set is all real numbers, so it's everything on this real number line, everything here. And if the complement will be not in A, so that will give us these numbers and these numbers. They're not in A. So when we describe it, we have to do two parts. First of all, x is still a real number, and x is less than -1 or equal to, because -1 is not in A, because as you can see here, x is strictly greater than -1, which means -1 is not in set A. If it's not in set A, then it must be in the complement, because the definition of complement set is that anything not in A. So if -1 is not in A, then it's in complement. But because 0 actually is in A, because x can be equal to 0, and so 0 is not going to be in the complement. So x is greater than 0. We have to get rid of the equal sign. So it's sort of like the negation we did before. So if it's less than or equal to 0, then it's greater than 0. If it's greater than -1, it's less than -1. That's the complement. Similarly, we can find a complement of B. So the complement of B, anything not in B, so let's look at this graph right here. So we have these numbers not in there, and these numbers not in there. So make sure you pay attention to the endpoints, because 0 is in set B, so x is less than 0. Or x is greater than or equal to 1, because 1 is not in B, then 1 should be in the complement. Okay, so when we get this, we actually can continue to do more operations. For example, we can do complement of C intersecting with complement of B. Okay, so complement always goes first. Treat a complement as an exponent. So the exponent goes before the operation. Think of intersection here as like a plus sign or minus sign. So first of all, we found the answers for complement of A, which is right here. We got the answers right here. And we found the answer for complement of B. So we do complements for each of them first. And we're just going to use the answer from here and there. And we're going to do the intersection now. So this one is a little tricky here because they all have two parts. And so we try to put, we can draw, again, drawing a number line will help us to do the problem. Okay, so what is complement of A? It's the numbers less than or equal to -1, or the numbers greater than 0, not including 0. So that's all of these numbers here, these and these. Now next, I'm going to use blue color to describe the complement of B. It's the numbers less than 0, so it's all of these numbers, and or the numbers greater than or equal to +1. So we're doing intersection, so which means we have to find the numbers belong to both colors, which have both colors. So by looking at the graph, we can see that these numbers here have two colors, red and blue. But these numbers here only have blue colors, so that it's not going to be in both of them. And these numbers only have red colors, they're not going to be in both of them. But these numbers also, they have two colors, so let's describe it. When we do that, also make sure we pay attention to the endpoints to check. For example, -1. Does -1 belong to both sets? And if we look, -1 is in A complement. -1 is also in the complement of B because -1 is less than 0. So we know -1 should be in the intersection. And or this part right here, x is greater than 1, is x equal to 1? And x is equal to 1 in complement of C. And x is can be equal to 1 because 1 is greater than 0. So we should include 1 there. Okay, well, and we can do one more. We can first do union, then do complement. Because parentheses go first, following the order of operations. And we have to find A union B, which we already have the answer here. That's A union B right here. I'm going to use that. So let's draw a graph for that. A union B, the answer is -1 to 1, and the complemented with anything not in here, so which will be this part or that part. And so we describe it. X is in R and x is less than or equal to -1 because -1 is not in the union. See, there's not equal sign here, not equal sign here. So that should be in a complement, or x is greater than or equal to 1. Okay. We're going to do one more, the intersection of A and C. So I'm going to put it over here. Intersection, so we have A right here. We put an A here from -1 to 0. And C is from -2 to, let's say C is from -2 to -1/2. So -2 is right here, -1/2 is right here. So the intersection is the part that with two colors right here. So both black and red. So we describe it as x is between -1 and -1/2. Pay attention to the endpoints. The endpoint is -1/2 is not in C, so it won't be in the intersection. Negative 1 is not in A, so it won't be intersection, because in intersection it has to be in both.